everyone. So now that we practiced factoring, it's really important that we're actually able to do something with it, okay? When we're factoring things, you need to make sure you understand that those are expressions. So the difference between an expression and an equation, expressions we simplify or we can factor, can do other things as well. But equations we actually solve. We solve to find different variables or unknowns. So expressions we simplify, and one way to do that is by factoring, and equations are something that we solve. All right, so back when you learned about factoring and then learned about quadratic equations, first you want to be able to identify if something is a quadratic equation. And so if it is a quadratic equation, you should be looking for the highest exponent in the equation being a 2. If the highest exponent is a 1, so like 2x plus 5 equals 7, that's a linear equation, okay? So you really want to know the difference, because then if you know it's quadratic, a couple things need to be true. First, in order to use the zero product property to solve it, you have to make sure that the equation is set equal to 0. So look at this equation below. First, I identified it's quadratic because the highest exponent is a 2. And so I also then checked to make sure it's set equal to 0. All right, once I've done that, the zero product property allows me to solve it by factoring. Now, not every equation is going to be able to be factored, but we're going to try factoring first, okay? All right, so I'm looking for the things that multiply to 27, 9 and 3, 1 and 27, and add to 12. All right, so first I'm going to factor the left side, making sure that 0 stays with me. Okay, and then that's going to give me x plus 9 and x plus 3. Now, the zero product property says that each of these can be set equal to 0 to find the value of x. So I would set each binomial equal to 0, or each product equal to 0, and then x would equal -9 and x would equal -3. And either of those answers could work. And the really great thing is that the fundamental theorem of algebra tells me that if that exponent is a 2, that I can have two real solutions, up to two real solutions. So my two real solutions would be -9 and -3. All right, let's try another one, okay? We can still have special cases and them be quadratic. So here's our first special case. It's two terms and it is quadratic, but it's not the difference of squares, although I know it kind of looks like it. Remember, you don't want to forget about that step 1 should always be look for a common factor. So I see that they have a common factor of x. I pull that out, and I'd be left with x minus 9 equals 0. Now, for whatever reason, this one, kids forget what to do with this guy outside, but the zero product property says that each factor should be set equal to 0. So I'm going to set x equal to 0 and x minus 9 equal to 0. And then solve. So x equals 0 and x equals 9. Now, what that's telling me is that if I plug 0 in for x, so 0 squared minus 9 times 0, that it's going to make this equation a true statement, and it does. Same thing with 9. If I plugged 9 in, I'd get 81 minus 81, which also equals 0, making the equation true. All right, another case, something like this. 2x squared minus 18. So because it's an equation now, I don't necessarily have to factor out the 2. As long as it's a number, I can't divide by a variable. But if it's a number, I can actually first simplify the equation by dividing every term by 2. Now again, you cannot divide by x. Like in this case, I couldn't have divided by x, but I can divide by an integer or a number. All right, so then the 2's would cancel. I'd be left with x squared. 18 divided by 2 would give me 9, and 0 divided by 2 would give me 0. Now, it's an easier thing to factor. So I factor using dots. It is the difference of squares, so x plus 3, x minus 3. Set each factor equal to 0 using the zero product property, and then solve. So we would get x equals -3 and x equals 3. So now those are two special cases. Now we also can always want to still have to go through that factoring checklist when we are solving. GCF, is it dots? Is it a perfect square trinomial? Okay. All right, so we're going to look here. 12x squared minus 75. I looked at that very quickly and I realized that there is a common factor of 3. So I'm going to divide all of them by 3. That's going to give me 4x squared minus 25 equals 0. Now I see that that's dots, so I can factor that into 2x plus 5, 2x minus 5. Now these are a little bit trickier. I'm going to set each one equal to 0 using the zero product property. So now I'm going to subtract 5. So 2x equals negative 5. And then I'm going to divide by 2. So x equals 5 over 2, or 5 halves, or 2 1/2. I'm going to add 5 to the other one. And then divide by 2. And so we get x equals 5 halves. So we have negative 5 halves and positive 5 halves. All right, GCF. No GCF in this next one, but do I have a perfect square trinomial? I don't know. Is this a perfect square? Is 25 a positive perfect square? It is. And is this double their roots? They are, so it will factor to the square of a binomial, a minus 5. All right, now that means there's 2 of them. So really you only have to set one equal to 0 because it's going to give you the same answer. So a would be 5. All right, guys, so that's a quick way to solve using the zero product property and factoring. Have a great day.